Hello friends, welcome to Silan Software. In this video, I will show you one nice project on data analysis, that is Zomato Restaurant Data Analysis. So in this project, we will perform exploratory data analysis on Zomato restaurant data to understand global restaurant distribution, popular cuisines, price range analysis, rating and voting behavior, relationship between cost rating and delivery services. So this is my project objective. So whatever the Python leverage for data analysis like NumPy, Pandas, Matplotlib, and Seaworm. Using these libraries, we will develop these projects. Let us start. First of all, I will import libraries. That is, import NumPy as NP, import Pandas as PD, import Matplotlib dot pyplot as PLT, import Seaworm as SNS. Now I will hit run. So NP is the alias of NumPy. Pandas for Pandas PD is the alias. PLT is the alias of Pyplot. SNS the alias of Seaworm. Matplotlib and Seaworm, these two library especially we use for data visualization. Okay, so now next point is, first of all, we will bring the data set. So already I have brought the data set, and my data set name is zomato.csv file. So this zomato.csv file I have taken from Kaggle. So this is the link. So this link I will share with you guys. So from the Kaggle, so you collect zomato.csv file, so you can download this data set. So from Kaggle I have taken, and first of all, this zomato.csv file I will bring to my environment. So in which way I will bring this zomato.csv file? You see, there is an option file. So you will click, then come to this option, upload to session storage. You click, then the data set where you have kept. I have kept in A drive. Inside the A drive, there is a folder data set. Inside the dataset folder, there is a folder Zomato. Inside that folder, this zomato.csv file is available. I will select, then click open, then it will come to this. So in this way, first of all, the dataset I brought into my environment. Google Colab is my environment. Okay, so now the next step is I will create a data frame. Create a data frame. So we know that how to create a data frame from a CSV file. Let my data frame name is df. So there is a built-in function read underscore CSV function. So when a read underscore CSV function When it is invoking by pandas alias PD, then it is returning a data frame. Within double quote, within function or within parenthesis, within double quotes, so I will specify the dataset name Zomato .csv file within double quote or single quotes. They depend upon you. No issue. So now in this way, so I will create a data frame. Let df dot head function. Head function returning first five records. Now I will hit run. You see, so one error is coming, that is Unicode decode error. UTF-8 code cannot decode bytes. So it is a very common error because the Zomato data set contains some special characters. So default UTF-8 encoding throwing error. So in this case, what I will do, so I will specify explicitly one parameter. So what I will specify, I will write encoding equals to, that is another format, encoding equals to, I can write Latin 1, encoding equals to Latin 1. So now it will safely reads all characters. Okay, you see, now I will hit run. And you see, I got a data frame. Okay, so again, I'm repeating the Zomato dataset contains some special characters. That's why default UTF-8 encoding throwing error. So in this context, so what we used, one parameter I specified, that is encoding equals to Latin 1. So now we got a data frame. Okay. So restaurant ID, restaurant name, country code, city, address, locality, etc. etc. Now we will check df.safe keyword. It is representing the number of rows and the number of columns. So 9551 number of rows, 21 number of columns. If we want to see the columns, df dot columns. Okay. So now basically these are the column names. So I hope everybody understanding. Now some basic pre-processing things that we will know df.info function. So it is giving the information detail about the data frame. So for this info function, I am invoking. Now I will hit run. You see, so range index 9551 entries 0 to 9550, that is. So column total 21 columns. These are the column names, and D types, data types, three columns. Data items are float, 64 types of data items. Five columns data items are int, 64 types of data items. Similarly, 13 columns data items are object types of data items. Memory 1.5 plus MB. So basically, this is the overall information about the data frame. Similarly, if I want to see the statistical information about the data frame, so we have to call describe function. So I will write df dot describe function. Now I will hit run. So it is giving statistical information, whatever the column is containing some numerical values. So for that column, some statistical information it will come. So restaurant, so I'm considering suppose for one column restaurant ID, this is the count value, this is the main value, standard deviation value, minimum value, and this is 25 what percentile, means basically first quartile, basically we say Q1 50%, that is second quartile Q2, 75% basically we say third quartile Q3. So 25 percentage values are less than from this value in restaurant ID column. 50% values are less than from this values in restaurant ID column. Similarly, 75% values are less than from this value in restaurant ID column. This is the maximum value. Same way, so we will understand for other columns. So overall, describe function giving statistical information about the data frame. Okay, so then we will go to the next point. Next point is you want to drop unnecessary columns. I want to drop unnecessary columns. Unnecessary columns. So one column, I will see. You see the column list. So one column is you see tweak to order menu. So I think it is one unnecessary column. So if really depend upon our analytical thought actually. So I suppose if I will fill this column is not necessary. This column has no impact with respect to analysis. So immediately I will drop this column permanently. So that's why so I will drop. So how to drop a column? So df, there is a drop function and it is a concept of data frame. So that's why I'm writing df dot drop function and I will select that column, switch to order menu. I copied and here I pasted here. Okay. Then for column parameter is axis equals to 1. Then if I want to drop permanently, so I will give another parameter that is in place equals to. Okay. So this is my drop function. Now I will hit run. Okay. So after that, if you check the f dot columns. Now I will hit run. You see, so that column dropped. Okay, permanently dropping a column. So I will specify one parameter that is in place equals to true. You remember. And for dropping column, for column, the parameter is axis equals to 1 also. Now after that, so I will check missing values. Okay, so check missing values. So this point we know df dot is null function, then dot sum function. Sum function. So actually is null function returning a boolean value. True or false if there is a missing value. True, otherwise it will return false. Then sum function. So returning the sum of missing values. You see if I will hit run. And you see for each column, so 0, 0, 0, 0, 0. This is a sum value. That means, so here there is no missing values in every column. Restaurant ID, restaurant name, country code. You see all columns. So 0. Okay. So in this way, we checked missing values. Then we will go to the next point. So now basic things that we discussed, how many number of rows, how many number of columns, then the information about the data frame, the statistical information about the data frame, checking missing values, So now the time came, we will start some analysis. And from the analysis, always we will get some insights. So first point, so analysis. Suppose I want to what country wise, country wise restaurant distribution. Okay, so what I will write. So country wise. So there is a column country code. So country code is the unique value which is representing one country. So I can write df of country, column name is country code. Df of country code, one built-in function I am invoking, value counts function I am invoking. Okay, so what is the purpose of value counts function in this context? So what it is representing the number of restaurants per country. The meaning is this. So in my intention is to find the number of restaurants per country. Suppose I will assign in a data frame. So let it country count. Suppose. Now I will call head function country count country count dot head function. Okay. So what is the purpose? Head function, it will display top five countries. Okay. With maximum restaurants. You see, now I will hit run. Okay. So what it displayed? First of all, value counts function representing the number of restaurants per country, and it is returning what one data frame. Let the data frame is country counts. This is my let it output variable. Then what I have written country count dot head function. So head function that we know it will display particularly in this context top five countries, one, two, three, four, five. So country, each country uniquely identifying by country code. So that's why country code I have taken df of country code. The meaning is the column country code of the data frame df. Okay, so country count dot head function meaning is it will display top five countries with maximum restaurants. Okay, so it will store automatically in descending order. Country code 1. So this country 8652. So number of restaurants per country. That means so country code 1 representing one country. That country has 8652 number of restaurants. Then the country code 216 it is representing one country. That country have 434 number of restaurants. In this way, the country code 215 representing one country, that country have 80 number of restaurants. In this way, I analyzed. Okay, so country wise what restaurant distribution. Now, so taking this, I will perform visualization. Okay, PLT dot figure function. Figure function is a built-in function. Fig size I will set equals to suppose 8 comma 5. 8 inch, 5 inch. 8 inch is width, 5 inch is the height. Okay, so then, so SNS I will call count plot, because we are finding the number of restaurants for country. So number of restaurants we are counting. For this, if I want to visualize the library Seaborn having a plot that is count plot, so that count plot we will see. So how to create a count plot? It is a built-in function. Count plot is a built-in function coming from Seaborn library. That's why it is invoking by Seaborn alias SNS. So we write sns.countplot. Okay, so explicitly I can write x equals to country code. Okay, taking the data frame df, data equals to df. Okay, so now plt dot title, one title you give. Okay, country wise restaurant distribution, restaurant distribution. Okay, now plt dot show function, plt dot show function. Now I will hit run. You see, we got a count flood. So country code 1 is the highest already. Before that, we have studied 8,652. And this, then 216,430, the country code 216,430, 215, then 214, 21580, okay, 189. Okay, so this plot, so title is country wise restaurant distribution. So this plot is representing this country wise restaurant distribution. Okay, so what we will got insights, the country code 1, the country code 1, so containing more number of Zomato restaurants. And you remember, you see the country code 1 representing the country India. Country code 1, country code. If you go through the data set, country code and which country code representing which country. Okay, so we will get insights. What I will get insights. You remember the country code 1 representing India. To India dominates the Zomato platform. That means what? That means in India, so the number of Zomato restaurants is more in comparison with other countries. Okay, so now I hope this analysis everybody got clarity, everybody understood. Now I will go to the next analysis. I want to see city-wise top 10 restaurant locations. So city-wise of 10 restaurant, restaurant locations, city-wise. Okay, so city-wise, so definitely in our data frame DF, there is a column city. So I can write DF of city. So you see, suppose I made a question, one analytics question I made, and you will think, The question is based on which column? Immediately that column I will consider. So city wise top 10 restaurant location. So that's why I wrote df of city dot value underscore counts function, value underscore counts function. Okay. Then dot head function of 10 10 10. Now I will hit run. You see city New Delhi 5473. So Gurgaon top first top 10 I found restaurant location. Top 10 city wise top 10 restaurant location in New Delhi 5473. In Gurgaon 1118, Noida 1080, Faridabad 251, Ghaziabad, then Bhubaneswar, Lucknow, Ahmedabad, Amritsar, Guwahati. Okay, so city wise, if I wanted to see top 10 restaurant location, so what I did, the column name city, I wrote df of city dot value counts function, then heads function. Now, if I want to visualize, okay, so visualization, if I want to visualize this point, so what I will write same things PLT. First of all, I will set the figure size. I will set fig size keyword, that is suppose 10 comma 5. 10 inch is the what width and 5 is the height. So df, okay, so this point I will directly copy. Okay, so I will paste, then dot plot function. I will call for creating a plot. Which type of plot? So if I will pass the parameter kind equals to bar. So one bar graph will create. So now plt dot title, one title. Suppose I want to give whatever, I will write top 10 cities. Top 10 cities with maximum restaurants. With maximum restaurants. Okay. Then plt dot show function. Now I will hit run. You see the overall the above analysis. Now by taking that analysis, I performed a visualization, and so one plot function I called, then one plot is creating, and within bracket I specified kind equals to bar. That means bar graph created, title of 10 cities with maximum restaurants. So function displaying the plot. And you see this plot clearly giving more what business insights. New Delhi having highest or maximum restaurants. So then Gurgaon, then Noida, then Faridabad in this way. So it is clearly identifying top 10 cities. Okay, so visualization is clearly giving insights. So what I will get insights? So major metros have the highest restaurant density. Then what density? So New Delhi, major metros, Gurgaon, Noida. So major metros. So what basically I will uh, get insights. So what I got insights. So I can write major metros. This is analysis. Have the highest, okay, restaurant, okay, restaurant density. highest restaurant density. In this way, I can write. So what we got insights. Okay. So I hope everybody got clarity. Then we will go to next analysis point. So online delivery analysis, online delivery analysis. So next, I will perform what I will check. So how many what online delivery that is going on? So online delivery analysis. So for this, there is a column you remember has online delivery, has online delivery. So one column is available in this data frame. So directly dot value underscore counts function I will call and I will hit run. You see has online delivery no 7100 and yes 2451. So this output, taking this concept, if I will perform visualization, if I will perform simply visualization, same way plt dot figure, first of all we will set the size. So fixed size keyword I am specifying equals to 6 inch comma 4 inch, 6 inch for width and 4 inch for height. So we will count. So SNS dot count plot. Here I am creating a count plot, especially in this context. So I will write take x equals to this column has, column name is has online delivery. Okay, then data equals to data frame df. Okay, so one title I will fit, one title we will specify online delivery, whatever I will write. Suppose I will write online delivery availability, availability. Then plt dot show method, plt dot show function. For show function specifically we use for displaying the plot. You see has online delivery and count. So no is what that means most restaurants do not offer online delivery, because from this visualization, so we are getting insights. So what I got insights. So what I got insights, most restaurants, most restaurants don't offer what online delivery, online delivery, because the no, if I will count, so it is what the volume of no is higher than the volume of yes. So this insight that we got. Okay. So I hope everybody got clarity. Similarly, we can do analysis, table booking analysis, same way in which way that we saw online delivery. So the volume of no is high, then the volume of yes. So now we will go to the next point, table booking analysis, table booking analysis. So for this, so directly what I can create a plot, table booking analysis. Okay, so let's see SNS dot count plot. Okay, x equals to, so there is a column has table booking. So this is one column, then data equals to data frame df. Okay, then plt dot title. Okay, so table booking availability. Okay, then plt dot show function. I will hit run. You see table booking, Hajj table booking and their corresponding counting. So what we got inside table booking is available in limited restaurants because no the volume of no is higher than the volume of S. And so yes volume is low, no volume is high. So from this what we got inside table booking. Table booking is available. Table booking is available in limited restaurants. So like this insight that we got. Okay, then we will go to the next point. So rating distribution. Rating. The next analysis is a rating distribution. A rating distribution. Similarly, directly I will perform visualization. So I am setting figure. So fig size equals to 8 inch for width, 5 inch for height. So now, so for this, I will create a histogram, SNS dot histplot. Okay, so there is a function, histplot function. It is coming from Seaborn. That's why I'm invoking by Seaborn alias SNS. Okay, so within bracket, so what I will write by taking what there is a column, you remember aggregate. There is a column aggregate rating, one column. Okay, so I will write bins equals to 10 and another parameter KDE equals to 2. Okay, so I will explain what this parameter. Then one title I will specify. So title is what? Whatever I will write, distribution of aggregate ratings. Aggregate of ratings. Then PLT dot show function. So that means one histogram I will create. Okay. So one histogram actually I will create for that hist plot function I have invoked. So hist plot function creating histogram, it will show frequency distribution of ratings. Taking the aggregate rating values, so it will display what? The frequency distribution. So in x-axis, so we have taken df of aggregate rating. So this column values that we have taken, then bins equals to 10. So what it is representing? So it is representing that it will divide the rating range into 10 equal intervals. Okay. So this is the meaning of bins equals to 10. KDE equals to true. Another parameter KDE equals to true. So uh, it will add what KDE meaning is what? Kernel density estimation. KDE kernel density estimation. So it is true. It is representing true means smooth curve. So it will show the overall distribution pattern. Smooth curve will create. And especially what KDA helps. So KDA helps what? Picks most common ratings. Okay, so KDE, kernel density estimation. So this parameter also that I specified within histplot function. Then title, then show function. Now I will hit run. So aggregate rating, you see. So column name aggregate rating in which way we have written. So aggregate. Okay, and you see this is my visualization. Okay, this is my visualization, and we will see most what it is representing the frequency distribution and what we are getting insights from this visualization, that is important. So most ratings in between this three, if you say 3.0 to 4.5, this. Okay, so within 3.0 to 4.5, most rating. So rating is high, so it is represent this. So from this visualization, so what I am getting insights, most ratings, most ratings live between, most rating live between 3.0 and 4.5. Okay, so this is my insights. Then I will go to rating text analysis. Rating text analysis. So similarly for this, I will consider a column so available in this data frame rating text. Okay, so directly I will call value underscore counts function, value counts function. Okay, so now I will hit run. So rating text. So I think T is lowercase. Rating text. So average rating text, this not rated. Okay, text analysis. Text analysis. Okay, so if taking this, if I will what perform visualization, so I will call count plot, means count plot I will create. So I will write sns dot count plot, count plot. Okay, so here suppose in y-axis I will take the values of rating text column, then comma data equals to df. Okay, so one title function, just I am adding a rating text distribution, a rating text distribution, then plt dot show function. So you see rating text distribution count excellent, this amount very good, good, average, okay, and not rated poor, percentage is very low, excellent, average is high. So what we're getting insights from this visualization. So rating analysis, basically text analysis. So on average that what restaurant is getting, so good rating, in so average rating is higher. Okay, so I hope everybody got clarity. So this is one analysis that we are doing. Then we will go to the next point. Average cost. Average cost for two analysis. Average cost for two analysis. The same way, so I will, okay, so I will write plt dot figure function I am calling, then fig size I am specifying. So 8 comma 5, that means 8 inch 5 inch width and height. So here, so I am creating a box plot. Okay, so box plot x equals to df of, so there is a column average. There is a column average cost for, okay, then plt dot title. So I can write average cost for, then show function I will, now I will hit. So x equals to df average dfx equals to sns dot box plot. Yes, this is this single quote I have forgotten. Okay, so this is the analysis average cost for two. So what we are getting insights, most restaurants fall under mid price range, fall under mid price range. So that insights we are getting. So what insights, most restaurants fall under mid price range. Then we will go to the next analysis point, that is cost versus rating relationship. Okay, so same way. So plt dot figure I am performing visualization. Fig size equals to, let's 8 inch is width, 5 is height. So here one scatter plot, SNS dot scatter plots. Scatter plot, suppose I am creating for this, there is a built-in function scatter plot. I am invoking by cborn alias sls. So x equals to one column. I will take average cost for two. So this column values I will consider for x-axis data items, then y equals to uh, aggregate aggregate rating column values, then comma data equals to df. Okay, so one title I will give. Okay, so one title vlt dot title, so that is cost versus ratings, then vlt dot show function. Now I will hit run. So you see this is aggregate rating and this is aggregate cost for two. So cost, so higher cost, you see, so this is higher cost, but in higher cost there is no higher ratings. So this is higher costs, so low rating that we have got. So this visualization is representing, because average cost for total. So this is the cost and this is the aggregate rating from this point. You see, so here. huge ratings that we have got, then some ratings. But when what here higher cost, you see it is representing low rating. That means higher cost does not guarantee higher rating. This is the insight that we are getting. So what insight that we are getting? Higher higher cost does not guarantee higher ratings. So this insight that we got from this visualization. Okay, average cost for two, yes, cost versus rating. Similarly, so I will do analysis. What price range versus online delivery? Price range versus online delivery. Okay, so directly one plot I will create count plot. Okay, x equals to one column. I will take price range. So x-axis, then y-axis data items. One parameter hue I am specifying. So it will display in the plot has online delivery. Has online has online delivery. So the column online delivery values will display in the plot. So that is data equals to df. Okay. So plt dot title. So one title we will give. Let price range versus online delivery. Okay. Then plt dot show function. Now I will hit run. You see, so this is the output of view parameter has online delivery, two values, no S. So this color is representing no and pink color is representing yes. So price range, okay. So what this is the counting has online delivery, no is higher than yes. So what we are getting insights. So mid-priced restaurants are more likely to offer delivery because this color, yes, is the pink color, this is blue color. So pink color here it is higher. So range is here what? Mid-priced restaurants. So because you see this color is yes, pink color yes means having online delivery. So where this color is more, so in this era. So this area is what mid-priced restaurants. So from this visualization, what we got insights. So mid-priced restaurants are likely to offer delivery. So this insight that we are getting from this visualization. Okay. So similarly, we will go to next analysis point, votes versus ratings. Okay, plt dot figure equals to, sorry, figure function fit size equals to let 8 comma 5 sns dot scatter plot. Once Scatterplot I am creating by invoking scatterplot function x-axis which column values I will consider votes, because votes versus ratings, for that so there is a column votes, and y-axis, for y-axis I will consider, so which column aggregate rating, because vote versus ratings. So votes versus ratings, if I will what do some analysis. So which column I will consider for x-axis and which column I will consider for y-axis. So votes for x-axis and aggregate rating column values for y-axis, that I will consider. Then data equal to df. Okay. So then one title plt dot title. Okay. So votes versus ratings, vote versus rating. So then plt dot show function. Now I will hit run. So you see, so votes versus rating, from this visualization, what we are getting, restaurants which have more votes. Okay, you see, these are the some huge votes and this person has some huge ratings. That means, so here, so very what vote percentage is low, rating is low. So restaurants with more votes have more stable rating. So this is the insight that we got. So restaurants with more votes have more stable ratings. That we got. This is the insights, okay, that we got. Then we will go to the next analysis point. I want to see top 10 popular cuisines. Cuisines. Okay, so there is a column cuisines of this data frame. So one data frame output variable. Suppose I am taking df of column cuisines. Okay, dot I will split str dot split. Okay, then based on the comma dot explode. Okay, so what is the meaning? So explode function converting each list element into separate row. So first of all I will write, then cuisines dot value underscore counts function dot head function of 10. Now I will assign result in a variable. Let variable name is top cuisines. Okay, so cuisine. So cuisines, the column cuisines of data frame that we considered for this case. So dot str dot split function. So what it is representing? Split multiple cuisines into a list. with the help of a separator. That separator is comma. Suppose North, comma Indian, comma Chinese, so it will convert into a list. Okay, so multiple cuisines into a list with the help of a separator. That is comma. Explore function meaning is converts each list element into a separate row. Okay, so then cuisines outputs dot value counts dot head. So top 10 we will represent the top 10 popular cuisines. Then the results I assign in a variable. Let the variable name is top cuisines. So taking this top cuisine one plot I am creating by invoking plot function kind equals to bar. That means bar graph I am creating fixed size I will set equals to 8 comma 5. Okay, then plt dot title of 10 popular top 10 popular cuisines. Then plt dot show function. Cuisines is not defined. Cuisines. Okay, top 10 popular cuisines, North Indian. So first, then Chinese, then fast food, then North Indian, then Chinese, then Mughlai, then fast food, then bakery, then cafe, then Italian. So these are the top 10 popular cuisines. Okay, so overall, this is the overall project, overall what we got conclusion. So what we got conclusion. So taking overall analysis, what we got, India has the highest number of restaurants, number of restaurants. Okay, online deliver or online delivery is not universal. Then cost does not strongly up ratings. Okay, user votes improve rating reliability. Okay, cuisine or cuisine type influences popularity. So these are the key findings, or this is the conclusion that we got. So guys, this is the overall Zomato restaurant data analysis project. So I hope everybody got clarity. Thank you.